Now we're going to learn how to solder some connections to a very small chip, a type of chip that we'll be able to then plug into a breadboard. So to show you what I'm talking about, here is a little chip that is a motor driver. It gives power to a DC motor. It's got some labels on the back telling us what all the pins are, and the business side that actually does the work is on this side of the chip. That's where the components are. We are going to solder some legs on that look like this. This is called header, and this is called male header. This side, the short side of these, will go into the board either like this or like this, and then the long side will be left sticking out, and it could be plugged into something. It could be plugged into Arduino pins, or it could be plugged into a breadboard, and we'll show you on a breadboard how that would look today. So first of all, we have a decision to make. Where do we want the header pins to be? If we want to leave the pin labels up, then we should solder the header on in this orientation. And I tend to prefer this when possible because it'll make it less mistake prone than if we had built it so that when it plugs in it looks like this. However, what if this chip was supposed to get really, really hot during operation? And in the case of a motor driver, it's possible that the chip could get real hot. Well, it might be that you need to leave it facing up for cooling, for instance. In this case, I'm going to leave the pin numbers, or the pin names, facing up. Now, first of all, you might notice that my little strip of header, and I have two little strips, it's too long. Actually, I'm going to begin by making the header the right size, and it's easy to do. You can just grab the header with some pliers, and, I went one to the wrong side, so that you can just break it off. It's got all these little places where it's very easy to break. So I'm going to do that again. I'll see if I can get it right the first time. Break it off. Good. So now I have some pieces of header that are the right length. How do I actually do the soldering? Well, actually, because it's going to end up in a breadboard, we can use a breadboard to support the thing during the soldering. And we do that by just putting it in there. You'll notice that the spacing is correct. I'm not trying to force anything that wouldn't naturally fit. And I'm not going to leave it standing way up. I'm actually going to press this chip down into the breadboard, and it can take a bit of force to get it to go down there. So the chip has just made these pins line up in the right spots, and they're just sitting there, just kind of hanging out. But look at that. They're held perfectly. So now this is in a really excellent fixture, basically. It can't go anywhere, and it'll be much easier for me to do the soldering I want. And now it is time to solder. In this case, my soldering iron, it's over here. It's on its little stand, but I'm going to pick it up. I'm going to be holding it in my right hand because I'm a righty, and this time I'll be introducing solder from the left side. So I'll have my solder in my left hand. So this will be the general mode of operation. I'm going to set the iron down in the stand. I'm going to turn on the fan just to keep all the smoke cleared, and I'll show you how we actually do the soldering, and I'll try to get you a little bit closer of a view. So what I'm trying to do now is get this pin, that metal pin sticking out, hot enough to melt solder, as well as that I guess in this case a square pad. The pad refers to the area around the pin, and I want to basically make that whole thing into a puddle. The pin won't melt, the pad won't melt, the solder will, but I want the puddle to be in that entire area. So I'm going to put my heat touching both the pin and the pad, and I'm kind of leaning into it in a kind of a diagonal way. I'm really trying to touch both, and then I'm trying to introduce a little bit of solder. I can kiss it into the iron, but it's more important that I introduce the solder straight into the joint. And I'm noticing that I'm having a little bit of a hard time getting it to flow in there. This probably is a sign that my iron is not hot enough, or it could be a sign of that. So I'm going to take this away. That actually solidified all right, and looking at that, it's about the right quantity of solder there that I ended up with. but I don't love how it looks. So I'm actually going to come over to my temperature control, and instead of 280, I might step it up to 330. I'll just go one step up, and as it's heating up, I want you to notice that there's some gunk on the iron, that black gunk. That's not great, and that's not really going to help our soldering process very much. Now, in our kit, you did not have a sponge included because that didn't come with the iron. What I would recommend doing is taking a household sponge, getting it wet, like pretty wet, and then you can rub that gunk off of the iron using the sponge. It'll sort of make a hissing sound as it happens, but then you can clear it off. The preferred way that we do it in the lab is using another material altogether, which is brass wool. So we actually have these little pots of brass wool, and I can actually just clean off the tip of the iron like that. So see how it came out much, much cleaner. So this is probably also going to help. Between the higher temperature and the cleaner tip, I think the second one will go better than the first. I'm going to now go to the opposite corner here. I'm going to apply heat. Again, I'm touching the pin that's coming out and the pad. And okay, so notice how this is all like kind of a gunky, not so good looking end here. I'm actually going to cut that off and get myself a nice fresh end, because having a gunky end can screw you up. Fresh end. And we'll try it again. I'm making decent mechanical pressure here. I'm pushing down with my right hand in that soldering iron. And now I'm going to go in. I'll kiss a little bit into the iron itself just to get a little bit of solder started, and it's flowing into the joint. The rest of the solder I can introduce straight into the joint like that. Rather than touching the iron, it's not a paintbrush. I can linger for a little bit, take the heat away, and that has cooled down. So now that was the second one I did. It's a little cloudy looking when it finishes. That's typical of lead-free solder. Leaded solder will typically be shiny when it finishes, but the leaded solder, the lead-free solder is more cloudy. And so I like to start with the corners, the four corners. I'll do this corner down here. That's about the right amount of solder, and I just sit there with the heat to let it kind of flow and make sure it's where it needs to be. That looks good. And please note that I'm manipulating the board. I'm moving it around to match me. I, the human, am the big person here. I'm the big thing that needs to be accommodated, not this little board. Move the board to you, if at all possible. I'm gonna hold there, and great. Okay, so it's melting right in. The smoke is being drawn off into the filter, which I like to see, and there we go. So then I would have done just the four. Obviously, I need to finish this. Now, one thing you might not want to do is solder this, then this, then this, then this, then this. Why not? Because the heat from your soldering iron is flowing into the board the whole time. So you actually want to minimize the amount of consecutive heat flows if you can. So I might do this one and then skip. So I'd alternate to there, to there, to there, and then maybe flip sides and skip some of these, something like that. So I'll just do that soldering right now, and then we'll skip ahead and see where we end up. Okay, we're all done, and now I can just pull this chip out. Oh no, that was silly. I bent the leg as I was pulling it out. I can fix that with the pliers or maybe just using my fingers. That is a risk. So this is pretty solid, and now this can be plugged in wherever needed, and then we could have other wires plugged in to the right and left, of course, to access these different pins. I don't expect these connections to ever disconnect themselves, so that's pretty solid, and it's about the right amount. You want to, ideally, this one here, this has a little bit of extra solder. This is about the right amount. You want a little more of a sort of a concave or sort of inward curve to the profile of those little solder mountains. But that's all about the right amount, and crucially, none of them are joining their neighbor. If this and this were touching each other, of course that would be a big problem, because then we would have made a connection between, in this case, ground and VMM, which would actually just short out the power supply. So it's very important that there's a nice space between each little solder pin and its neighbor.